This is a reminder class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate. Please don't share personal information during class for your own security reasons. So here's what I want to know. We've been talking a lot about friendship this week. So on the board, I want to know, what is one specific actionable thing you are going to do this weekend to be a good friend to someone? So go ahead, tell me on the board. Are you going to text your friend right now to meet up with them? Are you going to send your friend a nice message? Are you going to send them something else? I don't know, like a gift or something. Go ahead, tell me on the whiteboard, what is something that you will do to be a good friend? Are you going to have a phone chat with someone that you haven't seen in a long time? Actually call them instead of just text them? Go ahead, tell me on the whiteboard. So again, try to be specific in terms of like what's something that you can actually do. Like even right now, if you want to take a moment, text them, be like, hey, you want to hang out this weekend? That would be awesome. Awesome. I see arrow on the board. Looking good. Let's brainstorm. What is a specific, actionable thing you can do to be a good friend? Think of someone you have in mind. How are you going to be a good friend to them? Awesome. Hi, Dylan, Matt, Tony, Caleb, Chanel, Andrea, and Damien, and Michelle. Thanks for joining us. Go ahead, open up your ticket. Once we've got those links sent out, passwords in the chat box. I see Israel on the board. Thank you. Israel, I'm going to move yours down. There you go. Let's see here. Let's get a couple other people working on the board, please. Awesome. I see good idea from Arrow. Good idea from Israel. Looking good. I see Noah and Bradley on the board as well. Let's get a couple more people up there. Give you another 30 seconds. I see Oscar typing. Awesome. Looking good. Keep on working up there. I'm going to start going over these in just a moment. You can still keep on typing though. Hi, Jody. All right, Arrow, you said you are going to call your best friend, talk about your day, just have fun overall. Excellent. Israel, you're going to give her a message. She's going back to the Philippines for good. Gotcha. So that's important, right? Maybe even like handwrite a letter. That way she can hold on to it while she's in the Philippines, right? Drew, you said throw your best friend a surprise birthday party. Oh my gosh, that's super exciting. How long have you been planning that though? Hopefully you didn't just decide that right now. But that sounds super exciting. How old is your best friend turning, Dree? Let's see here. Oscar, you said you're going to hang out with your friends later on and tomorrow. Very good. Text your bestie a paragraph of how much she's been there for you. Oh, no, that's so nice. Caleb, you said you're not going to be around friends this weekend. There's still other ways, though, that you can still be a good friend, even if you're not there in person, right? So maybe Caleb brainstorm some ways of how you can just maybe send a nice text or send something encouraging to a friend. And then Bradley said call and check in. Cool. Oh, she's turning 18. So yeah, that's a good time to have a surprise birthday party is for those big birthdays, right? Awesome. All right, everyone, let's go ahead and keep on going here. We should be in the May 24th attendance ticket. I don't know. May 24th. Go ahead, give me a green check when you have it open and ready to go. Links are in the chat box along with the password underneath those links. I have 11 green checks so far. Still need a few more, just letting me know everyone's able to get in. Don't want anyone to have any issues with that. All right, waiting on Abelina, Tony. There's those links again, waiting on Chanel, Damien, Dusty, Dree, Dylan, Elias. Green checks, please. Jacob, Jody, Justin, Caleb, Matt, Michelle, Blossom, TJ, Whitney, Yolese. Green checks, please. Letting me know. Thank you. I've got 14 of them. Awesome. All right. So it looks like we're having no issues getting it open. As always, though, if you are having any issues, make sure you let us know in the chat box. All right. There are only 14 days left of school. Remember, we are on summer break once this quarter ends. So it's not just the end of quarter 4. It's also the end of the school year. Unless, of course, you have summer school. Then you have something else to do over the summer. But you still get a little bit of a break, right? So yesterday, obviously, there were no classes because I was out doing state testing for a couple of students. But you should have watched yesterday's recording and you should have completed the quiz from yesterday. Smiley faces if you got a chance to already do that. If not, make sure you get it done today before you go out for your 3-day weekend. Awesome. Thank you, Noah. Thank you, Orlando. Looking good. All right. Today we are going to be going ahead and doing our Unit 7 game day. I'm going to do a quick little review of what you should have looked at yesterday. Obviously, since I wasn't here, I just want to make sure that everybody understands what was going on yesterday. And if you didn't watch the recording yesterday, then today will be a good kind of boost to remind you of what we're doing. And then you can watch the recording and do the quiz later. All right. And then we will have our game today. Hi, Efren. Good to see you. Yesterday you had a 7C quiz with the recording, so make sure you get both of those done. Okay, that was due yesterday while I was out for state testing. Awesome. All right, so taking a look at our calendar here. Yeah, we have a game day today. Yes, Efren. So taking a look at our calendar, today is the 24th, and that means Monday you have no school. It is Memorial Day, so you have a nice 3-day weekend. When you come back, it's just a nice short 4-day week. You can see here that school will be ending in just 3 weeks. The last day of school will be on June 14th, and courses will be closing at 1 minute before midnight, 11:59 p.m. So make sure you get your work in before then. I recommend get your work in by 11 because the courses tend to they tend to have issues at the end of the quarter with everyone turning stuff in, and they tend to crash a lot. So try to get things in before 11 o'clock. All right, smiley faces, everyone. If this calendar makes sense, let us know if you have any questions about what's going on here. But again, 3 weeks and then it's summer break. So let's finish strong. Make sure we are on top of our stuff. Awesome. All right. So we have been talking all about bonding and electrons. I know, very, very close. So let's go ahead and take a look at this. So again, yesterday you should have watched the recording, but in case you didn't, or in case you need a refresher, I'm going to really quickly go over what yesterday's topic was. So yesterday's topic was all about electronegativity. And electronegativity is the ability of an atom to attract electrons. So if you're really good at getting electrons, right, then you have more electronegativity. If you're really bad at getting electrons, then you have really low electronegativity. And you can see a picture of these really big numbers here showing you electronegativity. So remind me again from yesterday, which of these is the most electronegative? Take a look at the one with the largest number of all of these. Which one is the most electronegative? Awesome. I got an answer from Efren. The answer is on the board, so just take a look here. Tell me which of these has the biggest electronegativity. Which one has the biggest number? Yes, I got an answer from Noah. Dorian, thank you. Yes. So you can see here, fluorine right here has an electronegativity of 4. So it is a very, very electronegative atom. Okay. Now we're going to take a look at some information about what makes things more electronegative. So in general, if you have more protons within a row, okay, the more protons you have within a row, the more electronegative you will be. So it increases from left to right. All right, because as you get more protons, those protons concentrated in the center are much better at attracting the electrons on the outside of the atom. Smiley faces if that makes sense. So as you go to the right, where you have more and more protons in the row, you get more and more attractive. Awesome. Now, nonmetals, you can see over here, these nonmetals, which are these orange and red ones, those ones in general are the ones that take electrons, right? So when we have ionic bonds, remember that metals will lose electrons, meaning they're not very electronegative. They don't hold on to their electrons very well. Whereas nonmetals will take those electrons. They're very greedy. They want those electrons. They will steal them away from other metals. And the other thing is that they are also going to be more electronegative if they are smaller. So remember that as we go down the periodic table, the electrons actually get bigger. So these ones down here are really big as opposed to these ones up here are really tiny. And so electronegativity actually increases as you go up the periodic table because smaller atoms, their electrons are closer to the nucleus, so it's easier for them to hold on to them. For larger atoms, their electrons are actually really far away, and so it's much harder for the nucleus to hold on to those. Okay, go ahead and really quickly give me a green check if this is making sense. So more protons in the row means you're more attractive to electrons. Smaller means you're more attractive, and in general, nonmetals are the most electronegative. Excellent. All right. Looking good. So that being said, we talked about this idea of ionic bonds already, right? And we said ionic bonds are when one atom takes a an electron and the other atom loses the electron. Now, the reason that this actually happens, there's an actual reason for this, and this is because there's a large difference in electronegativity. So metals, again, have really low electronegativities. They're very unattractive to electrons. Nonmetals, on the other hand, have very high electronegativities, meaning that they are very attractive to electrons. So if you get one that's not attractive and the other one that's very attractive, then that means the electron is going to be able to jump from one to the other. So we already learned this, right? An electron will jump from sodium to chlorine, making sodium positively charged, chlorine negatively charged, and then they are bonded together and they are stuck together in a stable arrangement. All right? Now, covalent bonds, on the other hand, do not have this large of a difference in electronegativity, and so neither atom can completely steal the atom from the electron from the other atom. Okay, so covalent bonds in general are there for sharing. Okay, so they have an electronegativity difference of less than 1.7, meaning that in general they're trying to share those electrons. Smiley faces if that makes sense, right? Ionic, you actually take them. Covalent, just like this idea of cooperate, or co-ed, or, right, all of those things, right, they're sharing, okay? Now, there is a case where there's kind of between complete sharing and complete stealing, and that is called polar covalent. So polar covalent, they actually have a small difference in electronegativity, resulting in unequal sharing. So for example, if you have two different nonmetals together, one of them is going to be slightly more attractive than the other one. And you can see that right here. This is hydrochloric acid, and hydrogen has a electronegativity of 2.1, chlorine has 3, and that's really, really close to each other, but which one is more electronegative? Tell me in the chat box, which one is more electronegative, hydrogen or chlorine? Which one has the higher number? Yeah, chlorine is a little bit more electronegative, right? So he's a little more electronegative, which means the electrons are going to spend a little bit more time around chlorine. And that means that in general, hydrochloric acid, all right, the chlorine actually acts slightly negative, whereas the hydrogen acts slightly positive. Because remember, those electrons are hanging around chlorine a little bit more, and the electrons are negatively charged. Okay, now nonpolar covalent bonds, there's no difference in electronegativity. They have equal sharing. This only happens between two identical atoms, like what you can see up here, two carbons. Okay, and they're symmetrical, right? Since neither side is stronger. Okay. Now, that being said, we talked about a couple different types of intermolecular bonding. And so metals have a sea of electrons that can move freely. So if you imagine the fact that what kind of things are our wires in our phones made out of? Like our wires for our phone chargers. What material is the wire for our phone charger made from? Or wires in general? Tell me in the chat box. Yes, copper. So copper is a really important metal because it's able to carry charge from the outlet to your phone. And the reason that it can do this is because metals like copper have a sea of electrons that can move freely. Okay, so that means they're really good at carrying electricity because electrons can move, and they're really good at carrying heat because heat is from electrons moving as well. That's why when you touch a hot metal pan, it burns. It's very easy to get burned from that, as opposed to like a wooden spoon. All right, and they can also be magnetic if those electrons spin in the same direction. Okay, so that being said, these atoms are also able to actually slide past each other, which means that you can actually, for metals, they're actually malleable, which means that you can hammer them. They're ductile, which means that you can stretch them into wires, and they're also very strong and durable. Strong and durable. I see, gotcha. I was like, Mr. Halcha, I don't know what metaphor you're trying to go with right now. Cool. All right, now the other type of intermolecular bonding we talked about was hydrogen bonding. And hydrogen bonding occurs between separate hydrogen-containing molecules. So it's going to happen between, for example, two different water molecules. Now, again, we just talked about this. Polar covalent bonds, which we looked at over here on the previous slide, have unequal sharing of electrons. So one side is slightly positive and one side is slightly negative. And those two parts actually interact with each other because remember, opposites do what? Tell me in the chat box. Opposites do what? Likes repel, but opposites do what? Yes, Era, opposites attract. So that slightly positive hydrogen is going to be or not very, but it's going to be slightly attracted to the slightly negative oxygen. And the result is that water is actually kind of a stronger liquid than you would expect, which is why if, for example, if you have a penny and you put droplets of water on a penny, it actually creates a dome shape. How many of you have ever seen the dome shape? You can also see it on like leaves in the morning time. Right? Or in general, if you just put a small droplet of water, you'll see it has a really nice dome shape. And that's called tension, surface tension. So water has really good surface tension, which even allows little creepy crawlies, little bugs to actually walk on top of it because of how strong these hydrogen bonds are compared to other liquids. Okay? Awesome. So that's just a really quick review again of what we went over yesterday. So let's go ahead and actually jump into our game now. I'm going to go ahead and remind you, you can go to kahoot.it either on a phone browser or a computer browser. You can also go on the Kahoot app. You can also double click on my name at the top of the participants panel, Brittany Fiorello Larkin. Double click on it, send me a smiley face, and that will open up a private chat. So you can play in any of those 4 ways, but you got to play in one of those 4 ways in order to get your 50 points for today. Okay? Then you are going to enter the game pin once I show it to you. You'll match the pattern on the screen, enter your first name, initial of your last name. Remember, just do your best because your grade's based on whether or not you answer all the questions, not whether or not you're correct. So just if you're not sure, do your best guess and you'll still get credit for today. Yes, Mel, Mr. Alch can resend the attendance ticket. Now remember, for the Kahoot game, I recommend make sure your name is actually on the starting screen. If you don't see your name up there, it means that you're not actually logged in. And if you try to join later, I can't guarantee that Kahoot will save your points. So I can't guarantee that when I download the report, you'll actually get points, okay? So try to make sure your name's on there. Otherwise, I recommend playing in the private chat. All right, I'm going to go ahead and load this up on the whiteboard for us. Play. Looking good. All right, let's have this load streak. All right, 914776. And I will read off this pattern like 10 times. Yellow, red, green, blue. Yellow, blue, red, green. Awesome. Shoshana, Arrow, Noah. Yellow, blue, green, red. Israel's on the board. Blue, red, green, yellow. Perfect. TJ, Efren. Yellow, green, blue, red. Again, if you need a private chat, please let us know in the chat box, or I can open one up for you, or so I can open up one for you, or you can double click on my name and send me a smiley face. Blue, red, yellow, green. Red, green, yellow, blue. Awesome. Dorian, I see you in the private chat. Thank you. Yellow, green, blue, red. I'm reading these off 3 more times and then we're moving on. Again, at that point, I recommend let's just do a private chat to make sure you get your points. I know, I double-checked the answers, so hopefully it all works. Green, red, blue, yellow. All right, no worries, Israel. I see you in the private chat. Thank you. And one more time, blue, green, red, yellow. Then we're going to move on in about 10 seconds. Make sure your name's up here. Or make sure you are in a private chat. I'm going to take a picture of this. Awesome, I see Dree on the board. I'm taking a picture of these 25 players. Perfect. All right, let's go ahead and get started. I only have 2 people in private chat. Again, if you need a private chat, let me know. This is an easy way to get today's 50 points. How many valence electrons does this sulfur atom have? How many valence electrons does this sulfur atom have? 2, red, blue 16, yellow 6, or green 8? How many valence electrons does this sulfur atom have? Red 2, blue 16, yellow 6, or green 8? Awesome. Thank you, Israel. Dorian, make sure I get your answer. 10 seconds. Thank you, Dorian. 5 more seconds. Got 21 answers. Again, if you're not sure, just guess. Awesome. All right. Looks like we chose between 16 or 6, which is the ones I was guessing you were going to do. Now, this is important, everyone. Valence means which ring should I be looking at? Valence means which ring should I be looking at? Or which shell should I be looking at? Yes, yes, yes. I see an answer from Efren. I see Andres typing, Dorian typing. When we're talking about this, yes, we want to be looking at the outermost or the outside shell. Yes, Jasmine, let me open one up for you. Here you go. Make sure you answer every question in that private chat, though, so I can give you credit at the end. Cool. All right. So valence means the outermost shell. So just looking at the outermost shell, not these two inner ones, how many do you guys see on this outermost shell? Let's make sure we understand this. All right. Correct your answer. What is now the correct answer now that you know that? Yeah, you should see 6, right? 1, 2, 3, 4, 5, and 6. Only 6. If you counted all 16, that would be the number of total protons, or sorry, total electrons, but that is not the same as valence. All right. Smiley faces if that makes sense. I see Arrow, Orlando, Rozzy, Andres, Mr. Alt on the board. Looking good. How many more valence electrons does this sulfur atom need to be stable? Red 16, blue 8, yellow 2, green 6. How many more does it need to be stable? Think about how many in total is stable. And if you have 6, how many more would you need to get to that number? What's that magic number? 15 seconds. I got an answer from Jasmine, from Dorian. I see Israel. Yes. Well, sort of. I'll go over that in just a moment, Efren. 5 seconds. Yes, it's actually called the octet rule. So just like that. And octet, just like octopus, reminds you of how many valence does it want in total. How many valence does it want in total if we know it's called the octet rule? Shells in total want how many? Like an octopus. Yes, an octopus has 8 legs, so the octet rule means it also wants 8 valence electrons. So that means that if you already have 6, how many more do you need to get to 8? Tell me in the chat box again, how many more do you need to get to 8? No, 6 plus 6 would give me 12. 6 plus what gives me 8? I see an answer from Arrow. Awesome. From Efren. So 6 plus what equals 8? Yes, 6 plus 2. So you need 2 more electrons right here next to these lonely electrons. You need to add another electron next to them. I know, it's a little bit confusing, Efren. That's why we're doing this review together. All right, no worries, Mel. I will open one up for you. In the future, Mel, you can just double-click my name and send me a message, and that will send me a private chat. Cool. All right. Rozzy, Mr. Alt, Orlando, TJ, Ashton on the board. Does this make sense? All right, so the innermost shell, remember, we don't count those when we're counting valence electrons. Valence electrons is only the outermost shell. And remember, the outermost shell wants 8 electrons in total. It's called the octet rule. So for example, oxygen also has 6. It wants to gain 2 more to be filled and stable. Red, not yet. Yellow, blue, yes. And yellow, it's starting to. 10 seconds. Make sure you're answering every question. Thank you, Jasmine. Thank you, Mel, Israel, Dorian. Make sure I get your answer. Looking good. All right. Next one. Atoms with less valence electrons like metals will want to, red, lose electrons, blue, gain electrons. So metals like sodium here, they have very few valence electrons. It has 1. So is it going to be easier to lose electrons or gain electrons? 20 seconds. Think about which is easier, to lose the 1 electron or gain electrons to fill the shell. I'm so sorry. Hopefully you got a chance to answer that question. Sorry, 1 second, guys, while I'm reconnecting to this. Cool. All right, so atoms with less valence electrons like metals will actually want to lose electrons. All right, take a look here. It's only got 1 electron here. Okay, sodium only has 1 electron. So tell me, is it easier to lose 1 electron or to have to get 7 more to fill up the rule of 8? Which one is easier, to lose 1 or gain 7 additional ones? Yes, it's much, much easier just to lose the 1. So metals will lose electrons. They want to lose electrons. Smiley faces if that makes sense. I know that's a tricky one, and I know it also logged me out for a moment. Awesome. Looking good. All right, Rozzy, Mr. Alt, TJ, Ashton, Orlando on the board. Damien is the highest climber, up 17 places. Way to go, Damien. Awesome. Does this make sense? Take a look here. Again, metals, like atoms on the left, are metals. They tend to lose electrons easily because they only have a few. The ones on the right, nonmetals, tend to attract electrons because they already have many. They just need a few more. Red, yes. Blue, starting to. Yellow, not yet. Thank you, Israel. Thank you, Mel. Thank you, Dorian. Jasmine, make sure I get your answer. 10 seconds. Again, if anyone else needs a private chat, let me know. Thank you, Jasmine. 5, 4, 3, 2, 1. Awesome. All right, let's keep on moving. Rozzy, Mr. Alt, TJ, Ashton, Orlando, the same one. All right, noble gases like this neon. Red have unfilled shells. Blue are not stable. Yellow are unreactive. Unreactive meaning they don't want to react. Noble gases like this neon, what do we know about this? Do they have unfilled shells? Are they not stable? Or are they unreactive? They don't want to react. 15 seconds. It's a tricky one. If you're not sure, just guess. Remember, guess to make sure you at least get your points. Looking good. Thank you, Jasmine. Thank you, Israel. Thank you, Dorian. Mel, make sure I get your answer. All right, it's a close one. Yes, this one, they are actually unreactive. Count up its valence shell. How many electrons does neon have in its valence shell? Tell me in the chat box, count them up. Look at the outside ring. How many do you see? Awesome, Efren. Awesome, Arrow. Count them up. Again, even if someone else has the same answer, you should still type it in. You should still be participating in the chat box because it helps to reinforce your own learning. Yes, they have 8 electrons on the outside of neon. And the rule is the rule of 8, or the octet rule, right? Octet rule equals the rule of 8. So if it has 8 electrons, and in total it wants 8 electrons, is neon happy? Tell me in the chat box, yes or no. If it has 8 electrons and it wants 8 electrons, is it happy? Is it satisfied? Okay, so the rule of 8 says that it wants 8 electrons, and we know it currently has 8 electrons. So is it happy? Yes, this is happy. So neon is happy, which means that it is stable. All right, so neon is stable and its shell is filled, right? It has all 8 of them, so it is completely filled, and it doesn't want to do anything. It's already stable. So the only one that makes sense is it's unreactive. Neon does not want to bond with anyone because neon is already happy. Remember, neon is like a happy single person that don't need no relationship. All right, smiley faces if that makes sense. So noble gases like this neon are stable, filled, unreactive. Excellent. All right. Mr. Alch, TJ, Rozzy, Arrow, Efren on the board. TJ streaking ahead. Does this make sense? Noble gases are the most stable elements and are unwilling to react because they have full shells, right? They have either an outer shell full of 8, or for helium, since it only has the small single shell, it's filled with completely 2. Red starting to, blue not yet, yellow yes. 10 seconds. Thank you, Israel, Dorian, Mel, Jasmine. Make sure I get your answer. 5 seconds. All right. Thank you, everyone. Thank you, Jasmine. An ion with more electrons than protons will be neutrally charged, positively charged, or negatively charged. If it has more electrons than protons, like this copper, what is it going to be? 20 seconds. Awesome. I see an answer from Mel. Jasmine, Israel, Dorian, make sure I get yours. 5 seconds. Thank you, Dorian. Thank you, Israel. Yes. All right, I did actually forget to change this. I meant to, but the answer is actually up here. This does end up being a negative charge. Take a look here. Electrons. Are electrons positively or negatively charged? Are electrons positively or negatively charged? Yes, electrons are negatively charged. Protons are positively charged, but if we have more electrons, more negativity than positivity, then overall we end up negative. Go ahead, give me a green check if that makes sense. Right, so more electrons than protons means more negatives than positives, means overall negative, negative charge. Excellent. All right. TJ, Mr. Alt, Rozzy, Arrow, Efren, and Michelle on the board here. A positive ion is also called an anion red or a cation blue. 25 seconds. That's weird. Is Kahoot giving you guys issues right now? Oh, no, sorry. Okay, just wasn't loading. 13 seconds. Oh, no! You forgot our memory trick. 5 seconds. Quick, quick, quick. 3, 2, 1. Here we go. All right, it's called a cation. Cation. All right, so remember, when you have a positive ion, you remember that the T in cation looks like a positive sign. So we can type it like that, cation. And if you have an anion, right, we can remember that little n in anion means negative. You could also remember it's kind of like an anti-ion. All right, smiley faces if that makes sense. Positive ions are also called cations. All right, TJ, Mr. Alch, Rozzy, Arrow, Efren on the board. Efren with the highest answer streak. Does this make sense? Let's take a look. All right, so losing electrons, you become a cation, positively charged. Gaining electrons, you're gaining negativity, so you become negatively charged, called an anion. So cations have more protons than electrons, anions have more electrons than protons. Red, not yet. Blue, yes. Yellow, starting to. 10 seconds. Work quickly. Awesome. Thank you, Mel. Thank you, Jasmine. Thank you, Dorian. Perfect. All right. Ionic bonds, when dissolved in water, like salt, okay, remember salt, when dissolved in water, does it not conduct electricity, red, or does it conduct electricity, yes, blue? Okay, so ionic bonds, when dissolved in water, no conducting electricity, red, yes, conducting electricity, blue. Remember, think about adding salt to that water in that video that we watched. As we added more salt, what happened to the light bulb? As we added more salt, what happened to the light bulb? 3 seconds. All right, they do conduct electricity. They do conduct electricity. Yes, Caleb, we saw this. As we added salt, they were able to, sorry, hold on, losing my train of thought. As we added more salt, it was able to conduct more electricity, which meant that the light began to glow more. TJ, Rozzy, Arrow, Mr. Alch, Efren on the board. Let's go ahead and make sure this makes sense. Let me show this to you here. All right, so ionic compounds, when dissolved in water, those positive and negative ions separate, and when we have free-moving charges within, or free-moving ions within a liquid, it can conduct electricity. Okay, so these can conduct electricity. They're also much stronger bonds because they're arranged in a cube or a lattice, so they tend to be solids, like salt is a solid. Red, yes. Blue, starting to. Yellow, not yet. Excellent. All right, was there anything else I wanted to mention from here? Oh, yes, and most of them, again, are soluble in water because of the fact that water is polar and can actually pull apart those positives and negatives, okay? Awesome. TJ, Rozzy, Arrow, Mr. Alch, Efren on the board. Rozzy making a comeback. Covalent bonds are when electrons are red, shared, blue, given and taken. Red shared, blue given and taken. Covalent bonds, what's happening to the electrons? 20 seconds. Think about that prefix co. What does that mean? Are they being shared or are we giving and taking away electrons? 13 seconds. 10 seconds. Thank you, Israel. Thank you, Mel. Thank you, Dorian. Jasmine, make sure I get your answer. 4, 3, 2, 1. Awesome. They are being shared, right? So for example, if we have 2 hydrogen atoms, remember that in total on this tiny ring, in total, how many do they want? How many valence electrons in total do these tiny atoms want on their first shell? Tell me in the chat box. Remember, it's not the rule of 8 here. It is, yes, they want 2 in total. So each hydrogen here actually wants 2. So what happens is if they share the 2 hydrogens, then they can actually feel like they have 2 in total. Right? So they stick together, they share these electrons, and now both hydrogens feel like they have 2 in total. All right? Era, Rozzy, Efren, TJ, and Mr. Alch on the board. Does this make sense? Let's take a look at this. Oh, here it is. Right? Ionic, the name's bond. Ionic bond, taken, not shared. So ionic bonds, they give and take electrons. Covalent sounds a lot like cooperate, right? So they are actually sharing together. Red, yes. Blue, starting to. Yellow, not yet. 5 seconds. All right. Looking good. Covalent bonds. Right? Hopefully you were paying attention during the last couple slides. Do they have a crystal structure red? Are they usually liquids and gases blue? Can they conduct electricity yellow? Or are they usually solids green? So one of these 4 things goes with covalent bonds. The other 3 are from ionic bonds. So think about what we just talked about ionic bonds a few slides ago. And now, what do you know about covalent bonds instead? 5 seconds. Thank you, Dorian. Thank you, Mel. Thank you, Israel. Thank you, Jasmine. I know it's a tricky one. They're usually liquids and gases. Oh my gosh, I did not trick you guys up at all for that. All right, good. So keep in mind that ionic bonds are crystals, right? Like salt. They can conduct electricity like salt when dissolved in water, breaks into positive sodiums, negative chlorines, and can carry electricity. And they're usually solids because of that crystal structure, that lattice structure. They tend to be more solid. Liquids and gases, on the other hand, tend to be our covalent bonds like oxygen gas, hydrogen gas, right? So we've got H2O O2, those are gases. We've got H2O, another covalent bond, which is a liquid known as water. Excellent. All right, Rozzy, Arrow, Efren, TJ, Mr. Alt on the board. Does this make sense? Take a look at this. So molecules that have covalent bonds tend to be liquids and gases since they're not stuck in the lattice. They're not stuck as crystals. It's easy to separate them. So they're easier to melt and boil. They also stay intact. They do not separate into positives and negatives because they're not made up of positives and negative ions. So it cannot conduct electricity. Sugar water does not conduct electricity. Red starting to, blue yes, yellow not yet. 5 seconds. All right, awesome. Let's go ahead, give a round of applause to our leaderboard here. Use your smiley face tool and give them a round of applause. Rozzy, Arrow, Efren, TJ, and Mr. Alt on the board. Great job. I'm going to save these. Hopefully this works. So sorry, what is today? Today is 5. There we go. Cool. Yes, that's awesome, Efren. You did a great job. Awesome. All right, guys. So that being said, there's also a couple people that were in private chats. So Dorian, Israel, Jasmine, Mel, you will also get your credit as well. All right, looking good, everyone. All right, so if for some reason you weren't participating in class today, you will need to do the alternative assignment. That's going to open up at 4 o'clock. All right, so thank you, everyone. That was a wonderful review. Here's your last word. Have a wonderful 3-day weekend, and I will see you all later. Bye, everyone. Thank you.